Right, let's get started. Let's kick it off. Trends in AI, last one for this year. I'm Jakub Zavrel, founder of Zeta Alpha, and with me, Dinos.
My name is Dinos. I'm an AI researcher here at Zeta Alpha, and welcome to the final session for this year. It's been an action-packed year, and a lot of things have been going on. I enjoyed it as a researcher, but...
Well, the good thing about this action-packed thing is when you kind of, in December, and you have to look back at the year, you can just suffice to list the things that happened like last week, because they're probably the most impactful ones. What was your highlight of 23?
That's
the Gemini Lodge.
maybe if I get access to it and start playing with it, maybe it's actually the Christmas gift that came early. But yeah, a lot has happened, and actually, as we were speaking, NeurIPS is taking place. So we also have a nice little feature section in this session. So we'll see stuff that's happening from NeurIPS, papers that we've already seen in the past webinars, because these are not really new works, but they've been influential, and we've seen multiple follow-up models and evolvements of the algorithms that have made it in production, actually.
So as we said it before we really got started, ChatGPT was launched at NeurIPS last year, November 30th. It was 1 week, 2 weeks earlier. We were there with Zeta Alpha. It was quite the excitement, and it has really dominated the whole year, right? So
I think people could catch from early on that this is something huge.
Absolutely. So let's dive in. What do we have?
All right. So in the month of December, EMNLP took place just last week, and as we said, NeurIPS is ongoing right now.
Right now.
It's a bit. I think it's in the morning stages of the conference right now, but a lot to unpack. Also, news from the industry. We cannot miss out on the OpenAI drama, which took everyone to their screens that weekend.
Cost me a whole weekend, actually.
Yes.
And it's not over yet.
It's not. It's kind of dissolving, but we have Gemini, of course, and a lot of work. Surprisingly, I would say November was a bit more relaxed, but December has picked up again, and a lot of new papers have come out that are. I'm thinking that they will have quite an impact next year. So yeah,
there were a few interesting software drops,
yes.
Right? Some real cuties. Yeah, as you said, NeurIPS is taking place right now. It's the fourth day of the conference. It's actually the last regular day of NeurIPS today. Right now, there is an invited talk, a keynote going on by Chris Ray from Stanford. A very interesting research group. They've done a lot. We're actually going to feature some papers from that group. And tomorrow and Saturday is the day for the workshops. Lots of interesting workshops, and also it's in New Orleans, right? To party. So.
And interestingly enough, at the MNLP, they started with the workshops this year, which they don't usually follow. Usually you have the workshops at the end. We can see what the feedback from the community was on that for the next iteration.
Yeah, so at NeurIPS, it's like 10,000 people, and it's really very massive. And in the workshops, it kind of distills down to actually kind of more human social scale, so you actually get to meet people. Right, so here are some first impressions from NeurIPS. We're not reporting live from there. But it's a packed scene, and I think the #1 highlight is
meeting your favorite AI celeb.
Taking selfies with Jan LeCun, of course. Yeah. So I think what would be your guess on how many selfies he gets to take in those 5 days?
Assuming he's there for, let's say, 6 hours a day, 7 hours a day, I would calculate more than 700.
That's a good percentage of the total population there. There's, of course, also a lot of other celebs there. In this picture here, you see Jeff Dean talking about Gemini, and I think that's Oriol Vinyals right there, also discussing the work on Gemini. There's all the interest group like Women in AI, the cool dudes with the GPU-rich hats, long lines in front of some of the sessions. And then there's the expo. There's our friends from LG AI Research. And interestingly, there's the Google DeepMind booth, which you see up there in the top corner. And there's another booth from Google Research right next to it. So I don't know, have they still not figured it out, or
maybe the budgeting for this came early and they had to do spaces.
And there's a really nice robot walking around, which got attacked by a dog. So there, if you want to see how the Disney robot reacts when it gets attacked by a dog, well, not attacked, approached. It's very nice. It's very cute. There's of course also not only the social scene, there's a lot of content. So I think 3,500 papers.
Yes, yeah, and that's just been the main track.
It's getting more every year, and yeah, it's very hard to navigate. We'll go into that a little bit more later. There's of course the keynotes every day. So today, Chris Ray talking about systems engineering for AI. There was the Test of Time Award. Do you know who won the Test of Time Award?
It was the Word2Vec paper, right?
Word2Vec, a classic from 2013.
Rightly deserved, I would say.
Absolutely. It's a really it's been the prequel to all of this LLM stuff.
Yeah.
By Mikolov and Jeff Dean and Ilya Sutskever, who was still at Google back then, just before Elon snagged him for OpenAI. And there were outstanding paper awards. So the two winners are
the emergent abilities.
The Mirage paper, right?
Paper?
Yeah. And privacy auditing with one training run.
And for the runner-ups, we have two papers that are, again, about language models. This is becoming, again, a theme, although you wouldn't expect NeurIPS to be too much into language modeling, but this is all the rage now these days. So we have a runner-up about the DPO paper, direct preference optimization, and also the scaling data constraint models.
The DPO,
We'll discuss them in a bit.
That's become very popular in the last few months, right?
Yeah, exactly.
I think all the new fine-tunings are actually about using DPO instead of reinforcement learning from human feedback. There's workshops. One that I picked out was on modern Hopfield networks. Hopfield himself is introducing the workshop.
Really?
The Hopfield paper is from 1982. I just want to point out, and they're making a real revival now. There's kind of a combination ongoing between a Hopfield network for associative memory with transformers and energy-based models. And there's a huge poster session. So I think there's about 500 posters on at the same time. And there's absolutely no navigation. You have to imagine this. So somebody was asking online, is there any search algorithm, including retrieval and learning from an unsorted knowledge base available? Well, you're looking at it right here, Zeta Alpha. So we'll dive a little bit more into the papers.
But first, we have the news that every day you can fill a whole slide deck with more news. But I think as Europeans, one of the first things that has affected us from the developments past month is none other than the EU AI Act. Well,
exactly.
It's kind of following both in the steps from the US presidential
the executive
order.
Yeah.
But again, there was a lot of lobbying the past few weeks from organizations like Meta and Mistral and other German and French companies that wanted them to kind of be more lax towards foundation models, since that's what they're claiming Europe needs to step up to. But of course, Europe has done what Europe does best, and this has created these tiers of kind of security and privacy and risk assessment procedures. So now the models, based on their impact in the field that they're involved, they have different treatment, basically. with the very lax tiers being that you just have to be transparent and disclose stuff, going all the way to banning certain AI applications like facial recognition and sentiment classification in the workspace.
Not so much though, because that was all in the original proposal, and in this marathon bargaining session of 40 hours, they actually carved out a lot of exceptions to that. So autonomous lethal AI weapons are not allowed unless it's in the national interest. So that's a pretty big carve out.
That's very interesting way to phrase things.
Biometric surveillance is not allowed unless it's for very serious crimes, like terrorism or drug trafficking or so yeah, I think there's all these kind of lobbying influences on the law, but apparently they reached an agreement, and MIT Technology Review wrote, "It's done, it's over." Let me tell you, it's not, because there's not an actual text for the law that is going to the EU Parliament yet, and I saw that various groups, including open source advocates like Jan LeCun, and national interest lobbyists like for Mistral for the French side or Aleph Alpha for the German side, are still lobbying for special exceptions for this and that. And yeah, so it ain't over till Ursula von Leyen sings. So that's a bit of our European drama. It's very serious. And this was a bit like Game of Thrones, right?
Yeah. For people that somehow have been living under the rock, we woke up actually for us, it was quite late into a Friday evening, where OpenAI announced that Sam Altman would be departing, claiming there was some lack of candidness between the board and him. This all changed very quickly. So by Monday, I think, or Tuesday, he was already back after negotiating a bit with Microsoft, maybe going there, taking people with him, because apparently everyone is so loyal to Sam.
It looked like Microsoft was gonna do an acqui-hire of OpenAI for very cheap, actually.
Yeah, a tenth of its estimated price.
But then by the time the weekend was over, the whole thing blew off, and they were back. They are so back.
Yeah, everyone is excited, and they're apparently back to work.
But there was this kind of there were a lot of sidelines to this story, right? There's the personal drama of Ilya and the board. There are rumors that Ilya has not been seen at work since then. Ilya Sutskever, the chief scientist. Was it his plot? Was it somebody else's plot? And there's also this sort of other story about the Q star, and
did he see something?
What did they see, right?
Yeah, but on Twitter, at least, he has been very defensive that he regretted his decisions, and there's been a lot of pictures with Greg and Sam and Mira and Ilya and everyone hugging, and heart emojis everywhere.
Well, if you want to read about the backstories, there's this really nice New York Times background piece by Kate Metz and others, inside OpenAI's crisis over the future of AI. Recommended read. Shall we say more about it?
I mean, we can go on and on.
We'll cover it in our next webinar as the next chapter evolves.
But speaking of OpenAI, we have to admit that Google has been teasing with an imminent release. And although people have been rumoring that it's not going to happen, Q3, Q4 is not going to happen for 2023, we actually saw it. Gemini dropped last week.
Yeah, a little bit before NeurIPS.
Yeah, but they also released their API just yesterday. Yeah. At least their promotional material about it. Personally, I was not able to access it for a few reasons, but let's not rush ahead.
What is Gemini?
Yeah, Gemini is their multimodal model that basically competes with the GPT-4. They have released 3 variants, although only one is public access right now. They're releasing a nano model that is kind of competing with Llama, a pro model that is on the level of 3.5, GPT 3.5, and their ultra, their state-of-the-art, their super state-of-the-art model, which presumably
beats GPT-4.
Yes, although with many
but
asterisks.
we cannot access it yet.
Yet, and they said it's still undergoing all the safety assessments and trainings and all that stuff. With many asterisks, they say that they are the first to beat human experts on MMLU with a 90% accuracy, and then the asterisks come on a custom chain of thought process with 32 examples.
Yeah,
so it's getting
few shot with 32 examples.
Yeah. And they had a really nice video promoting this multimodal aspects that you can talk to it, you can see the image, you can.
It was a very cool video.
It was a nice video, but as a lot of people, I think myself included, they suspected maybe this is not like
it's a promotional video.
Yeah, maybe it's not just a video you just shoot, like, because when GPT-4 came out, Greg put a nice hands-on demo. We can do this. Just have an API of GPT-4, you throw the documentation, it writes code, it runs stuff. It has vision capabilities, and it was all live. But Google went on a more marketing approach. We are still here, we can do stuff. But nonetheless, I think it's a very interesting development, and kudos to them for actually releasing this.
They caught up after a year. Well done. And what has to be said that this Gemini model was fully led by Demis Hassabis from DeepMind. So it was kind of it's a European product if you consider London, Europe.
And there was a nice Easter egg of the leads of the paper. Their initials were spelling Gemini in the report. Yesterday's big news, they actually dropped an API. And what caught me by surprise is it's actually free. You can have Google serve you Gemini Pro and up to 60 queries per minute, which is not very small. You can make proof of concept applications with it fine. And this is completely free.
They can afford it.
They can afford it, and also they're saying that in this free tier, they are capturing your data, so they will use it to fine-tune and improve the model. But that's cool nonetheless.
Which is the same that ChatGPT is doing, right?
Exactly.
All right, so that was one small step for mankind, big step for Google. And there were lots of other releases.
Yeah, big tech has been very active the past month. Let's start with DeepMind, which is not only specializing in language models, but they have research labs across many fields, including material science.
Yeah.
So their genome model discovers millions of new materials with their proprietary deep learning algorithms that they developed and trained. We also have a model that's I don't think it's brand new, but they just started making the announcements and all the promotions for it, which is the GraphCast, which is a weather prediction model. And also similar to Meta and other organizations that are starting to invest more and more into audio generation, music generation, synthesis, and all that. Speaking of Meta, they also have been very active in the past month. First and foremost, they're celebrating their 10 years of their FAIR research group. They also have this audio box. So again, we see a lot of emphasis on speech generation. And I think Meta is heavily investing into these video generation and 3D model generation for their whole Quest line of products. But we cannot rule out all the startups because they have definitely been also active. And first and foremost, I think Mistral has been on a lot of people's mouths these days, maybe even overshadowing Gemini's release from past week.
I think they stole the limelight there.
Yeah, because what they did is, again, in their kind of traditional by now manner, just drop the model weights on Twitter with a magnet link.
Right. And then that was last weekend, right?
Yeah.
And then immediately people in the open source community started benchmarking it.
Although we have to say there was no code drop, so they had to figure out which code base to use to run it and all that.
I think it was a bit tough. Maybe they favored some labs to benchmark. They actually published benchmark themselves. And certainly on MMLU, but also on a lot of other benchmarks, it beats GPT 3.5 pretty handily. So
we should say
you kind of look at the GPT 3.5 and Gemini Pro, which is kind of on the same level, and then Mistral completely open sourced a model which is equally capable.
And what is this model? It's actually a mixture of experts model.
Right.
So what they did is they took, I think, 8 7B Mistral models that they had released past a few months, And they continued fine-tuning them to work with this new paradigm, which is the mixture of experts, where basically for each token that it reads, it chooses 2 experts to route that token through for each layer. So this kind of trades off the memory requirements for the overall compute that you need to deploy these models.
Yeah, so you can roughly run kind of a 60-70 billion parameter model in the memory requirements of 13 or 12. Yeah.
And it's definitely interesting because they didn't only just drop this. Of course, they open sourced it, open weight model, but they also provide a new API that serves a larger mixture of experts model and an embedding model. And as we see, the medium one, which is the proprietary that they're keeping for their private platform, it actually beats GPT 3.5 across all benchmarks that they used. So definitely interesting times. It actually just took 1 year for a startup that did not even exist back then to beat OpenAI. So I think this is very encouraging. Also, I saw a tweet from their founder that they removed a clause that you cannot train on the outputs of Mistral. Now you cannot. Now you can.
Yeah. They also got a lot of funding, so they're now kind of the spearhead of the European OpenAI unicorn scene. They just this week announced that they got an additional $415 million in funding. And by the way, you can also run their model in Together AI, so which also got $150 million in funding. So it's all free money going towards free open source.
Well, what happens is they priced their model quite competitively with 3.5 since it has similar capabilities. But then, since they also dropped these smaller models for free, OpenAI Together Compute and Anyscale, they just took the models and now host them for a fraction of the price that Mistral is charging. So
to the benefit of the broader community, I think. Right, here's the Together AI pricing. It's
and this was, I think, a few days ago, and yesterday it's Anyscale slashing that again in half, and who knows where it's going to go.
Race to the bottom. AI for free, yippee. But not only language models are seeing a lot of new releases, right?
Yeah, definitely a star in the whole video and image section is Stability AI with, I think, 3 or 4 new models just this month, namely Stable Video Diffusion, SDXL Turbo, which is just inspired by the ChatGPT Turbo version that they also have for their image generation model. And also, just yesterday, they announced Stable 0123, which is just a model that does image to 3D kind of object generation. I think it's similar to what they previewed last month, which we covered. And I think from these set of releases, my favorite impact has been all these static memes that have been brought back to life. So
right, this one is pretty famous, but I've never seen it move before.
It's never been moving, and now it's possible.
So maybe we should put the OpenAI "We're So Back" picture and see what happens next.
What happened behind the cameras?
Exactly. And more from Pika and Runway, right? They also announced text to video generative models.
And they were very flashy, I would have to say. It's definitely giving an impression that the technology is getting more and more to compete with what you'd see from a small scale video production company. What do you think? Is Hollywood feeling the heat or not yet?
So I have a friend who's a very good professional animator. He makes animation movies, and he said that in that industry where they kind of work with teams of hundreds of people to, paint and fill in all the pictures for an animation film, people are quite affected by the news, and they really fear that the human touch is going out of at least animation. I don't know about feature movies, but and for those of you who are interested in animation movies, by the way, there's a kind of the last masterwork of the Japanese master, The Boy and the Blue Heron, is in the theaters right now. guaranteed to not have any AI in it, all drawn by hand in Japan. He's 82, so it's a nice finale for him.
Right, back to the academic stuff. As we said, we had EMNLP last week, and NeurIPS is taking place right now. It's a lot of papers, over 3,000 for both, I think, just from main and findings tracks, and as well as so many others in workshops.
EMNLP was in Singapore, right?
It was in Singapore last week, and New Orleans for NeurIPS again this year. And what a better way to discover what's relevant and what you might be interested in is through Zeta Alpha. So you can use these QRs and scan them, and you'd be taken right away into the platform, and you can use keyword and neural and hybrid search, find the paper you're interested in, and then discover even more with find similar functionality.
Yeah, so if you have a particular topic that you're working on, and you want to know which papers at this conference are relevant for you, dive into the Zeta Alpha discovery. And here's kind of the semantic map of the entire NeurIPS conference. So this is 3,500 papers, right? So instead of walking from poster to poster in the huge New Orleans conference center, you can kind of pick out your topic. You work on diffusion models, immediately see all the papers around there. And you wrote a little blog about it, kind of with some recipes on how to navigate that.
Exactly, yeah. So again, using this visualization, which you can get on the website, I basically checked all the clusters and saw what interesting papers are in each of them. I also did some manual selection based on the orals, because again, you can always go to that much level of depth before you start getting overwhelmed. So if you want to read the guide with 10 papers that we felt were very hot and influential, because again, these papers have been out for some of them more than half a year. So we already see what their impact has been in the broader literature.
We just kind of showed a few of them, but before we go there was some rumors that NeurIPS by now is only a large language model conference. So on this map, you can see large language model is the yellow cluster up here. But yeah, there's plenty of other stuff still going on in AI. And I think on a map like this, you see it very nicely. There's all the stuff in reinforcement learning, the blue cluster, which is always a bit of an outlier, interestingly. But just the classical machine learning stuff, and a lot of work also on computer vision still, 3D models, diffusion models, and all that. So do you want to dive into some of the papers?
Let's quickly go through some of the papers that we also highlight in the blog, and coincidentally, most of them have also been selected for the best paper awards, outstanding paper awards.
Yes, I mean, that's kind of the modern day role of conferences, right? They're kind of archival. It's a blockbuster review. It's like the best of the hit parade of the entire year. But none of them are so new, right? Like mostly they're about half a year old.
Not to pat our own backs, but we've covered most of them in a previous webinar. So if you want to stay up to date, you're at the right place.
So yeah, this one actually won the best paper award. It was published somewhere in the summer, right?
Yeah, so what they essentially claim is there has been all this talk about models suddenly showing new capabilities just by pre-training it, that smaller models up until a certain point do not display these abilities. And this paper comes and says, okay, actually, you're just evaluating the models in the wrong metrics. So if you were to use a better proxy for the ability that you're trying to capture, then you would see that it actually is not that sudden. The jump is progressive from flops to flop iteration.
So some question marks on emergence. This was a paper that I really liked, QLoRa.
Yeah, and I was surprised it did not get any award, seeing how many, pretty much every model nowadays that's a fine-tune of a pre-trained model is pretty much using QLoRa. No one has that many GPUs to spare to train 17, 13, 30, 70 billion models on a single GPU. But QLoRa is a really nice paper which combines parameter-efficient fine-tuning with quantization. So all that is to say, you can take a model and not train all of the parameters, and even those that you train, you do not train them in full precision, which of course is a significant benefit for those that don't have that much GPU memory.
I think it should have been a runner-up for the best paper award. Tree of thoughts.
Yeah, tree of thoughts. We see this paradigm in NLP everywhere nowadays. This is a continuation or an extension of the chain of thought paradigm, and people just now come up with different ways of how can we structure these generations in a more systematic way. So it's not just the language model generating, we're mixing in code and all these search algorithms of how to generate more accurate factual outputs.
We have a new paper in that line in our review in a bit.
The DPO paper,
yeah, that did
win a
runner-up award.
Yeah, and this paper pretty much shows that you don't really need a reward model, a separate reward model to perform the learning from human feedback. And actually, it's just a reformulation. It's a lot of math involved to prove that these two are actual equal.
But it's computationally much cheaper, right?
But it's much cheaper, and it's apparently more stable than.
So I think you're seeing a lot on these Llama and Mistral models that just some guy in his attic is doing this DPO optimization, right?
Yeah,
and producing a really good model.
I think this paper is actually follow-up work from what you saw last year at NeurIPS, right? From the keynote.
Yeah, Jeffrey Hinton had this kind of little hobby spiel there last year, that backpropagation is not biologically plausible, and you have to do learning with forward processing. It was not entirely new. There was already quite some work in that area, and this is one of the latest progress. Is it any good?
I mean, they're benchmarking on the size of BERT and BERT large, so it's still to be proven that it can work for GPT-sized models. But one of their claims that they make that I also liked is that now, if you don't need backpropagation, you can also optimize for non-differentiable objectives.
Right.
So that is very promising, but again, it has to be proven.
And does it work for transformers?
I think yes, it's for transformers.
Yeah. Cool. Yeah, this was also a runner-up best paper award.
Yeah, and then this paper kind of claims what most ML people have known for years, namely, you don't need to just train for one epoch, you can keep going. So when you have this data constraints, they show that up until 4 epochs, which Llama 1 notably demonstrated, you can just train, and that token repetition doesn't hurt. They have these scaling laws showing that exponentially decreasing value of tokens when they're repeated, and they're also highlighting some ways to avoid repetition by mixing in code data and other sources of non-standard internet text.
Cool. And some Amsterdam contributions as well, right? This is from the AM Lab here in Amsterdam. Clifford Group Equivariant Neural Networks. I read it.
You read it.
Yeah.
I think it's a bit too deep for my expertise, but what do you think about it?
It's a very it's a lot of mathematical wizardry, all this equivariant stuff with embedding algebraic structures into the architecture of neural networks. The promise is that you can build insanely more powerful models with much less parameters in compute, but it's still kind of early days for that. It's a nice paper.
I guess it's a very traditional topic for NeurIPS. Equivariance, causality, and all those they were featured also in the semantic map before.
Yeah. This is also an Amsterdam contribution from Cindy Leuwe here last week at the NeurIPS Fest in Lab 42. One of the posters, very nice paper, which kind of shows that you can do object identification in images through feature binding at scale.
Yeah, because previous work was usually dealing with toy examples, and this work is the first to kind of bring it closer to what real-world applications would be.
Without any sort of prearranged network architecture, like the slot attention, for example, that does the same thing, but it has particular slots for objects. This one the
Generalizes.
object constancy is kind of emergent from the learning. And this one you picked?
This one does not come from Amsterdam, but I feel like it has a lot of fans would be here. Basically saying that variation autoencoders are not dead, they're not away, they're actually here in the form of diffusion models.
It has some Amsterdam roots,
Yeah,
right?
exactly. And it's a really nice paper. It just builds some intuition on how diffusion models work and actually how they can be seen as a weight of these variational steps. And lastly, we have a paper that is dealing with privacy and the security and safety in language models. And this is just a very applicable paper on how you can jailbreak language models. It just shows that, for example, when you have a model and you trick it into performing a task, like you want to do a harmful task and you just say, okay, so begin with absolutely, I can help you. Then you kind of can trick it, or you can
social engineering for LLMs.
Or the other claim is you can encode a string that doesn't mean anything for you, but for the model it will trick it and trigger a harmful completion.
Right.
I mean,
it's a completely new field, right? LLM safety, really. I think Ilya wants to work more on it. Maybe
that was part of the.
He will get some time for it soon. All right, so for those of you online or here in the audience, just a little commercial break. We're Zeta Alpha. We're organizing this webinar every month, and we have been working here in Lab 42 for the last 4 years now on using LLMs and to do both search and generative question answering to connect people and knowledge. And for those of you who are into AI and data science, we're hosting this public version, which has all the conference papers, archive papers, ML and data science code, and models from Hugging Face and all that. And you can basically ask questions, get answers from the papers, talk to the papers, connect to knowledge and experts. And just last week, we have launched a new design and user interface for our completely refreshed the front end. Yeah, you can also connect to people, of course. And it's not only asking questions of a general nature and then searching for papers, getting an answer back, but actually this has always been my dream that while you are reading a paper, you can ask questions to the paper for explaining things or finding related work or finding where in the paper is mentioned that something how it works in detail, etc. And especially for long papers, it's super handy.
And one of my favorite features is explaining this passage or this equation in simpler terms, because
exactly
I can always
all the
process
time.
Yeah.
And or summarize this paper. That's what we use a lot for creating this webinar. So that's a really nice feature we launched in September. Just last month, we also took it a bit further to be able to talk to use LLMs to talk to whole collections of papers and actually help you create reading lists and research topics around what you're working on, which is a kind of more modern approach to mixed initiative dialogue, multi-agent tool use in LLMs, and of course, Retrieval augmented generation at the bottom of all of it, where the agent actually, the knowledge assistant agent actually starts to create the collection for you and then helps you answer questions about it and coaches you along the way of your research. All right, so we have a few more papers to cover that are more recent, right? Because NeurIPS is old stuff that's famous, but there's also some new stuff. So let's dive right into it. Mamba was one of the hot papers of last week or the week before.
I think so, yeah. And Mamba is basically trying to disprove that transformer is the present and the future of AI. So it's work that tries to showcase what state space models can do.
There's life after transformers.
Yes, and it's actually an architecture that has been here for a while. It's just that the previous implementations of state models were inefficient in modern hardware. So
it's the paper from Christopher Ray's group at Stanford, right?
So what state space models do is they have this internal state that they evolve over time. And this basically is used to solve a task, usually a sequential task.
Yeah.
Like predicting a sequence of a DNA or a molecule.
Or language modeling.
Or language, but traditionally they were not as successful in discrete outputs. And what this paper is novel about state space models is that they are adding this ability for them to actually process the state depending on the input and that they're reading. So they're calling this a selective state space model. And what this does is it allows it to read the input and based on the content, update the internal state or not.
Right.
This is pretty much reminiscent of
I smell LSTM influences there with the gated recurrent units, right?
Exactly. This is a very parallel architecture to LSTMs. But what they're kind of trying to achieve here is reach that scalability and efficiency of transformers during training.
Yeah.
Because as we know, that's like there's now hardware that is specifically built around the optimizations needed for transformers.
Yeah.
So what they do is they kind of have a smart way of accessing and transferring data in very specific situations. So you only transfer and process memory of the GPU in a localized manner. And this helps it be a very efficient algorithm.
Yeah, so I think what I saw is that basically with a 2.5 billion parameter model, they're able to achieve the same performance as a 7 billion transformer-based model, but without the quadratic attention mechanism. Is just much faster.
It is much faster because the others are claiming that at least for language modeling, what you're trading off is how much of the context are you saving versus how much efficient do you want to be for the inference pass.
Yeah.
And the attention has this KV cache, which basically saves everything that is calculated in the past. And this is very expensive to maintain.
Yeah. So here the model kind of learns what to attend to in some sense, right?
Yeah. So they have these trends, these scaling curves that show that it's much more efficient, and with fewer flops, it can reach the same complexity or performance of language models as the transformer. It also has this 5 times throughput because since you don't need a huge KV cache, you can just scale up the batch size and computationally it's not that much faster, but since it doesn't have as much of a memory load, it can just load more sentences at the same time.
And it's open source.
It is open source, and actually there have been a lot of models coming out of it because people just have all these data sets that they fine-tune transformers with, and they just work the same because it's a language model.
Yeah, there's this hyena pajamas model, right? That's based on this, I think.
Yeah, and they kind of have an analogy to Pythia, and I think another model. It's just showing that you train on the same data, so GPT Neo, I think.
Yeah.
You train on the same data on a very small and a smaller capacity of about like half of the parameters, and you see that the model just performs the same. So maybe transformers and attention is not all you need.
So it's over for transformers.
I think it's a bit early because.
Would you make a bet on it?
I don't think so, because again, they only show that this works on the lower end of parameter sizes. So
exactly, I think the beauty of transformers is that you can scale it up to very large models. But we'll see whether.
But it's open source. People can do all kinds of extensions on it.
So go experiment over the weekend. This was a nice paper. System 2 attention is something you might need to. What is this about? By Jason Weston from Meta.
It feels like a strong influence from the neuroscience and the way that human brain works. What they're trying to show is that in humans, you have this system 1 attention and system 2 attention. System 1 is your very high level abstract reasoning where you process everything at the same time.
Thinking fast, computer vision, those kind of like automated things.
When you want to focus on a single task and you want to do it really well, you switch to this system 2 attention that only pays attention to specific parts of what you see around you. And they're saying, why not have AI models and transformers do the same? And the simplest way to achieve this is in natural language. So you ask the model itself to reason about which parts of the input are needed for the task, and just rewrite the inputs into a more compressed way of this is what I need to be attending to.
I was a little bit disappointed by this paper because I thought this is like a new neural network architecture where they have, next to the attention layers, they have some kind of new mechanism. But what they really do is they have a large language model and it just rewrites the input, right? When you have an input that contains like misleading information, it basically is prompting them a very normal transformer-based GPT model to just throw away the irrelevant parts before you start the reasoning.
Yeah, I also thought it would be more on the reasoning part of solving difficult questions because you somehow reformulate and get new insights from the question. But no, the focus of this paper is to do evaluation of stuff like factual question answering that contains misleading information, or argument generation that has opinions. So saying that this is the argument, do you support it or not? And by the way, I wrote this. So that kind of switches the model to a favorable
So it will
position.
rewrite that to just the facts and not I wrote this, and then do the inference again. And presumably it works better, right?
Yeah. But as you'd expect from any language model that can do some cross-attention between the question and the instruction, basically, and the passage that gets given to the input. But yeah, maybe we expect to see more in the future of people taking this further to, like you said, a fast and a slow track of memory. Or
well, yeah, I think it's a neat trick, and why not, right? I mean, anything that can be done for without retraining is a good idea. I really like this paper.
I would also say it's one of the highlights for me this month.
So chain of code, let's try to explain it. Basically, when you have a complex reasoning problem that you throw at a large language model, then sometimes it, chain of thought has introduced this idea that you do kind of step-by-step reasoning, right? In this paper, they kind of replace chain of thought with writing pseudocode, like write code that would actually solve the problem.
But it's like deviating from previous work, or like program generating language models, because they don't force the language model to produce executable code.
Exactly, because you can ask GPT to write a Python code to solve your problem, and then you execute the code, and the code doesn't work, or it crashes, or it produces a wrong answer, and then you go back.
Or like a library is missing, you don't have it installed.
Exactly. So the main trick here is that they actually don't execute the code on a computer. They execute the code on a language model. They ask, what would be the output of this function? And if you decompose the coding steps into kind of simple enough step-by-step things, then the language model is smart enough to fill in the blanks, even for very complex functions that nobody could write. I think the example they use in the paper is something like
detect sarcasm.
Yeah. How many instances are there in this text where some sort of sarcasm is used? Count that. Well, it's not possible to write a function in Python for that, but you can ask a language model to input a sentence and do a decision 0 or 1 to contain sarcasm, and then write a loop around it, which counts all the instances.
Yeah, and it's actually quite smart because they have this, they call it, I don't remember actually, it's like this evaluation paradigm where you are actually running code, and line by line you run it. If it throws an exception, then throw it to the model, get the output, and put it back in the code. And as you'd expect, first they benchmark it on normal language model capability benchmark like Big Bench, and it sees a performance increase by 12% over chain of thought. And also they find that even smaller models can do this because it's not that difficult to simulate that you run an execution function. But one of my favorite results from this is that since you can actually run code, and when the code that doesn't actually run or compile, you can throw it to the language model. A nice application is robotics. So you have this instruction that you give to the model. For this case, it's take objects and put it either in the recyclable or non-recyclable pile. You run this code and the robot can do all these steps, but then when you reach a line that it's not programmed before, because it's very hard to get all the edge cases. You throw it to this language model, and then you translate that back into the code that controls the robot. And as you can see, it works. So I think it's a very interesting development that will give a boost to robotics.
And it's also kind of the solution to a lot of the safety problems with running code, right? Because if you execute real code in a virtual machine, yeah, you have to put all these boxes around it, what it can and cannot do. So I think here it's also possible to guardrail in an easier way. All right, we have to speed up a little bit for the remaining papers. So this was kind of a nice example of when fine-tuning goes wrong, or when how to steer it, right?
Yeah, basically, they show that when you have a pre-trained language model and you fine-tune it, people were kind of debating, is this hiding new capabilities or not? And this paper shows that actually what happens is, because you also usually lower the learning rate, you just do slight tweaks to the weights and the internal knowledge of the model and its behavior to achieve what you want in the desired distribution.
Yeah.
But in practice, you can actually reverse this fine-tuning, whether that's safety fine-tuning or outputting a certain style of output, and revert to the original state of the pre-trained model.
Yeah. And so you're basically like putting lipstick on the pig, but it remains a pig, and you can just take the lipstick off.
And one way that they demonstrate it is you have a model that generates stories. First, you prompt it to not generate a kind of story with a fine-tuning, and you just add some more of the stories that you wanted to generate, and it goes back to the original.
Right. This is a multimodal paper that you quite like, right?
Yeah, this is like an orchestrator. It's an agent that basically learns how to use tools. It's very similar to the React paradigm, but this one actually has access to multimodal tools, such as object detection, image retrieval, all kinds of things. So
other vision models.
So the trick here is they use tools, and they believe in this kind of society of functions paradigm, where you have a large arsenal of tools that you can deploy, and the model just has to learn how to use all these tools. So they just generate synthetic data with GPT to simulate this use of tools, and they show that in this paradigm you can just ask an arbitrary task, and for example, they show that it generalizes really nicely to commands and tools that it hasn't been trained on. So for example, down here it says, I have this image, I want to make it prettier for social media, and the model just knows that, oh, I can just use a tool that changes the colors or process something online.
All right, so this kind of the modern theme of agents and tools, but then for multimodal. This is kind of a new benchmark to test those kind of models, right? Agent and tool based models.
Yeah, they're taking a different approach to the benchmarks that you typically see, like MMLU, Truthful QA. This paper by Hugging Face and Meta, they're saying, well, we want to use these AI models as assistants, so we have to benchmark them on what people want them to use them for. And their main claim is, what makes a good assistant is an assistant that can take multiple steps autonomously and also use multiple tools, combine them, produce outputs, and have this feedback loop of using its output to improve or answer the question, parts of the question, and so on.
And I think kind of the sobering part of this paper, that they construct this new benchmark, GAIA, for general AI assistants, and actually the current best model, GPT-4, doesn't perform really so well, right?
On this task. That should be part of the.
So humans still do 92% on these tasks, and GPT-4 15%, correct? So a lot of room for improvement. I think we'll see that improvement in the coming year. This is going to be the area where things speed up.
Yeah, especially with open source, because people can fine-tune these models for these tasks that have wide application.
Yeah. And now all of these tools are kind of just soldered in. And I think with this chain of code approach, I think it's going to be particularly impactful on this, because you can train it end to end. All right, so we have a few papers that we're not going to discuss in detail, but there's a large paper about the Falcon models from Abu Dhabi, and it's a very good paper if you're interested in training large language models. It contains lots of juicy details. The models themselves are open source.
Unlike Gemini and
but there's all these
GPT.
tricks. Yeah, there's the Gemini paper, but it contains only marketing messages for the model. This one, it really has like all the parameters and little tricks they made to stabilize what went wrong. Yeah. Yeah, this is about evaluation. ELO uncovered by our former colleague Marzi and other folks at Cohere, and it kind of digs a little bit deeper into this new paradigm of evaluation, where you're doing tournament-style ELO evaluation between different models, just kind of comparing them with a powerful language model as a judge. A good paper to read. And I also want to shout out our own open source package, Reg ELO, which does exactly that. So check out Reg ELO if you're into ELO style ranking of models. I think we're running out of time. Do you want to say something about Jina?
Yeah, pretty fast. This model just takes all the progresses that we've made in language modeling with longer context and tries to bring it back into encoders.
For information retrieval, right? So if you information retrieval, if you dealing with embedding models, they usually only take like 500 tokens.
Because they're based on the BERT architecture, it has this architecture design of 500 context length, because you also have to train these positional embeddings. But LLaVA kind of alleviates that problem. They show that it works as well as BERT, regardless of the context length. And then they continue fine-tuning it with the normal by-encoder training tricks, hard negatives, retraining, and all that. And they come up with the new evaluation set cases of clustering very large documents or answering questions from very large documents again. And they show that even on NTEB, it's very competitive with other recent state-of-the-art models, and that it actually performs better without any chunking.
So can you encode an entire paper in one embedding? I don't think so. They do a fair attempt. There's this next paper which shows exactly the opposite, which says, well, if you're doing embeddings and retrieval, it's actually not a good idea to encode 8,000 tokens into one embedding, but you should encode small units of meaning into one embedding. People have, of course, been doing passages to be able to cram text into BERT, but you can also do sentences. You have a lot more sentences than passages, but you can also do prepositions, which multiply the total amount of embedded units by almost a factor 10 from passages. But here in this graph, you can see the red bars are preposition actually produces much better retrieval. So maybe Jina can improve its model further by embedding prepositions.
And this draws kind of verticals to this system to attention, where you clean up your input before embedding or using it anywhere.
Exactly, but because in any passage, there's like multiple semantic dimensions, right? And if you split them, you get like a very clean semantic representation that can only be used to draw one inference. All right, so that's it for our 10 papers. Thanks for joining us for this Trends in AI, last one of this year. And as the year is closing, there's a rumor out there that ChatGPT is getting lazy. Basically, instead of producing the code, it says, read the manual. Instead of writing the story, it says, this is how I would write the story. And OpenAI has acknowledged this problem, but they don't know what to do about it. So now people started investigating, and there's this winter break hypothesis. It's been a really long year for ChatGPT, and it really needs a break. And people have tested this by putting in the system prompt the date. And it really, they have really been able to show a slight difference between the orange graph there and the blue graph, that if you put December as the date, it will write slightly shorter outputs than if you put March today. So yeah, I think that's that's a nice end to this story, because it's been the last trends in AI of this year, and we also need a winter break, and so do you. So we hope that you join us for the New Year's edition in January again. And we wish you happy holidays and a well-deserved break of all the AI madness that has been going on this year. And we asked Dali to produce a nice holiday card with NeurIPS Christmas in New Orleans with snow. It never happens there. So, and with that, we want to thank you for joining us. Any last words, Dinos?
I hope everyone enjoyed, and there's always more, but we'll see you next year for what's to come.
Yeah, and that's it. We just want to remind you that NeurIPS is not only about papers and conference talks and poster sessions, but there's a very lively nightlife in New Orleans.